welcome to the first keynote with sound ever. So I want to quickly introduce Walter Brown to you. Last year during CPPCon, I kind of had the honor to meet Walter for the first time. Really, I think we spoke prior to that, maybe like a few words like hi, you know. But so we had a lot of good conversations, and I was like, yeah, actually, I know he's a good speaker. But then he gave a really great lightning talk, thanking his mentors. And that kind of was, yeah, I really would like to maybe invite him to the conference. He also expressed that he would like to speak at here. And so I decided that basically the only option is to let him keynote, because I think he really is a great speaker, and I'm really, really curious what he has to say. And so I'm going to hand it off to Walter. Thank you for coming. And
thank you.
Let's.
Guten Tag. Als ehemaliger Deutschsprecher danke ich allerherzlichst für die Einladung, hierher nach Berlin zu reisen, um an Meeting C++ 2019 teilzunehmen. Meine Damen und Herren, es freut mich sehr, Sie heute als Abschlussredner ansprechen zu dürfen. Leider bin ich etwas außer Übung, Deutsch zu sprechen, also halte ich den Rest meines Vortrags auf Englisch. Nochmals vielen Dank. Before I get started, as some of you know, it has been my custom in recent years to ask your help in thanking someone who has been very, very important to me for the overwhelming majority of my life, and that would be my wife, who, in honor of this occasion, has made for me, she fabricated a brand new tie. You probably can't see it from where you are, but it's all zeros and ones in your honor. So please help me thank her. And if you will please indulge me for one more moment before we get underway. This year has been somewhat sad for my family, as a number of our close relatives have passed away. Most recently, my sister's husband died, and I was not able to attend the funeral because I was traveling to Europe at the time. So with your permission, I would like to dedicate this talk to his memory. All right, let's get underway. Some preliminary thoughts. Let's keep this in mind. A computer is a stupid machine with the ability to do incredibly smart things, while computer programmers are smart people with the ability to do incredibly stupid things, right? I hear you agree with me, yes. But let's also keep this in mind. Sometimes we discover unpleasant truths. And whenever we do so, we are in difficulties. Suppressing these truths is dishonest, so we must tell them. But telling them will fire back on us. We will be written off as unrealistic, idealistic, revolutionary, gullible. And besides that, telling these truths is not without personal risks. Vide Galileo Galilei, right? Most of us come to these conferences to improve our knowledge. We would like to become experts. How do we become experts? The answer is the same in all the fields I've seen. Step 1, learn the basics. Step 2, study the same material again. But this time, Concentrate on the details that you didn't realize were important the first time. And there's always more to learn, as we all know, perhaps especially in C++. Learning is cumulative, it's revisionist, it's iterative, it's incremental, so your knowledge always increases. But your appreciation of what you don't know increases also. How do we start? One of the best ways to learn is the study of examples. It is useful to examine both good style to be emulated, as well as poor practice to be avoided. The skillful critique of imperfect art, which we often term critical analysis, is a powerful technique to improve the quality of one's own work. In other words, as we heard 2 days ago, study others' code, learn from past successes, learn even more from past failures. So during this talk, I will show you a lot of very small examples. Now, I chose those because I've seen them firsthand in production code. These are not examples from student programs. This is from production code. A few of them have been reported to me from reliable sources, so I included them. And I've seen these often enough that I've become, well, annoyed, if you prefer, irked, peeved, irritated, or provoked, and perhaps all of them. Bad code annoys me. It just really, really does. And after more than 50 years in this business, I've seen an awful lot of it. Some of these examples I will discuss in quite some considerable detail, but others we're just going to look at and shake our heads. How can people write that? Now, I must tell you ahead of time that in order to avoid embarrassing anyone, and certainly to avoid what we call legal entanglements, I kept the essence of each code snippet, but I sanitized them. So I hope you will not actually recognize the sources. I did also launder all the identifiers. But you might recognize them anyway. But I've done my best. I also have a few other things for you today, a mix of examples of what I will simply call unfortunate outcomes that should never have reached production. Some are silly, some are funny, some are just truly horrific. I have some selected advice for you from other experts, some recent, some somewhat older. Some cultural influences that can make our jobs hard. I will show you perhaps one or two useful, at least in my opinion, C++17 and C++20 features. And we'll have a few bits of fun along the way. Coincidentally, some of my topics do overlap talks by some of the other speakers at this conference. I'm sorry about that. Please do go see their talks for additional depth. They were good talks, and I recommend them. And please be forewarned. I've said this for a very long time. Because of my training and my long years of experience, I do have some rather strong opinions about computer software and programming methodology. I know that all of these opinions are not yet shared by all programmers, but they should be. And as you grow older, approaching my age, you will discover this, that when you need to pay tuition and a mortgage, you're willing to put up with a certain amount of stupidity so that you can take care of your family, which comes first after all. But once those bills are paid, your tolerance for idiocy shrinks quite a bit. Trust me. Let's have just a few bits of fun before we get serious. I found these things and I felt I must share these with you. This is a real product. I couldn't find a bottle of that here today. I also learned something. That if that's a hobbit, then that must be a hobbite. And finally, a very short story. Once upon a time, there was a C++17 programmer who walked into a pub and ordered 1.000 tick, 000 tick, 119F root beers. The proprietor said, "I'm sorry, I have to charge you extra. That's a root beer float." Yes, I know. But the programmer said, "Well, in that case, just make it a double." And now the time has come to speak of many things, as Lewis Carroll wrote almost 150 years ago. Lewis Carroll's real name, of course, was the Reverend Charles Lutwidge Doxson. He was mathematical lecturer at Christ Church College. And he liked to take pictures of little girls, especially one named Alice. Hence the name of his books. So first, some examples for you. Unprofessional results. These should never, in my opinion, have ever reached production. Let me start with a personal story. Quite a number of years ago now, we bought a GPS for our car. It looked approximately like that. Now, as you know, in GPSs, at least most of them that I have seen, they come built in with a directory, so you can put commonly used addresses there, destinations you drive to frequently, so you don't have to keep entering them over and over. And there's often a special entry that's pre-labeled home. So you put your home address there. Well, in our family, we don't use home, because if that GPS gets stolen, I don't want thieves to know where we're not. So instead, we entered our home address in the general directory under my name. And I always do last name first, family name first. So I entered under Brown, W.E. Yes, my initials are Webb. By the way, my late father-in-law's initials, his first name was also Walter. His initials were WWW. We invented the internet way before its time, right? So the first time, in our own town, we practiced using the GPS. Even though we knew our way around, we wanted to learn how to use the equipment. And the first time it took us back to our home, I almost drove off the road laughing. I almost had an accident. Here's what it speaks as it arrives home. Please listen carefully. There's some road noise in the background. I will play it for you twice. Also watch the screen. I will show you visually what it says. But listen if you can.
Arriving at Brown West East, on right. Arriving at Brown West East, on right.
So it changed my name to a pair of directions. I'm sorry, that should never have reached production. Should never have happened. If you work for this company, I feel sorry for you. Here was an online ad for a place to work. Among other things, they want to know if you have work experience, whatever that is. More interestingly, do you speak United States? I live there, and I don't know if that's what I speak. I don't think so. Here's a product, 24 ports, but in French, there are only 16. So I guess 8 of them are only for English. Somebody wants to sell me a mouse that's 1 cubic centimeter in size. I think I'd lose that almost immediately. Even worse, it's wireless. I can't even pull it up by the tail. Somebody wants me to enter a 92 meg length pin. I have so many problems with this. First of all, why are you giving me both a minimum and a maximum length when they're the same? Why are you measuring ping length in bytes? And why is it 92 meg? I can't remember that. Can you? I didn't think so. I don't know about you, but I don't listen to undefined, 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 and more. How many employees work at your company? A survey, less than 10 or October through 50? How can our colleagues let that happen? And yet, right? You read it. Shall we say this is unfortunate? A list of countries that includes the United Nations. How can we let that happen? Here's a calendar, kind of unusual. There's the 7th and there's the 9th. The only thing I will tell you is this is not my code, trust me. And now that we have Howard's library, this should never happen again, right? How can we let that happen? Or that? Or that? Or that? And here's a pop-up window. Error in error handling. Sorry, no handling possible. And my choices are to press OK or what? How can you leave a user like that? And now a story. This is very unfortunate. These matters are not harmless. They really aren't. We laugh at them, but they affect people. In 1991, there was a tracking computer for a missile system that converted time values from decimal to binary with an error of 1/10,000th of a percent. That's 1 part in a million. That's pretty good. That's pretty good. But if you run that clock for 100 hours, the accumulated error is more than 1/3 of a second. And in 1/3 of a second, a missile can travel 1/2 kilometer. And guess what happened? The missile slipped through the defense system and detonated, killing 28 people. When even 1 in a million isn't good enough. This is what I meant by horrific. Our code affects people because we don't know where our code will end up. Copy and paste is endemic in our industry, right? The code you wrote last week might, in a year or 5 or 10 or 20, end up as part of software controlling an X-ray machine delivering a treatment to a cancer patient. We have to get it right, people. We have to. Another example. Just what you want. Mistakes on a stealth fighter. Crossing the international date line. What happened? All their systems failed, including navigation, part of communications, and fuel systems. You really want a fighter plane to malfunction like that, right? How can we let that happen? Here's still more. I mean, there's a never-ending set of these examples. An update lets anybody bypass the fingerprint scanner with a pack of gum. That was this year. GPS devices made more than 10 years ago had a finite amount of storage for their data counting system, and that number maxed out earlier this year. The consequences of that are horrific. Coastal and marine automated stations went offline. Imagine what that does to shipping and safety. The New York City government wireless network died, affecting city services ranging from police to sanitation. And many, many more bad things happened because somebody failed to learn from Y2K. Yes, I know, Y2K is already 20 years ago, but surely we should remember these lessons. Although I must say, companies used to take phone calls before they sold their products, just before Y2K. Customers wanted assurance that the products were Y2K safe. There was a phone call to a manufacturer of pencils who wanted to be sure that the pencils were Y2K safe. They were. You know, and it never ends. Researchers are detailing vulnerabilities in a popular operating system that runs on more than 2 billion, that's not a typo, 2 billion devices worldwide. VxWorks is a real-time operating system for devices like medical equipment. You really want a malfunction in medical equipment, right? Elevator controllers, right? Satellite modems, and more. Apparently 200 million devices are vulnerable. And the bugs have been there since 2006. And they commented, the patching process will be long and difficult. Yeah, right. And just what you want, you're driving your car and there's a stack trace on your screen. Think of the safety implications if you take your eyes off the road at the wrong moment. How can we allow that to happen? So please permit me to call your attention to the Forum on Risks to the Public in Computers and Related Systems. It's been around since 1985. It's moderated on behalf of the ACM Committee on Computers and Public Policy. There's the URL. I recommend you have a look. All the previous digests are still there, going back now about 35 years. Also, there's a monthly column in the communications of the ACM. Edited and distilled highlights from those columns appear bi-monthly in ACM SIGSOFT Software Engineering Notes. And all the recent and important columns are online at that URL, and I recommend that to you as well. So let's take a look at C++. Now, I don't want to insult, excuse me. I don't mean to insult your intelligence. I'm going to show you some very, very simple pieces of code. And I want to comment on how easily even simple code can go wrong. Let's start there. Now, don't shout out answers, don't raise your hands. This is not a quiz or a test or anything. But do you see anything wrong here? Because I do. This would not pass my code review most of the time. Uninitialized local variables are usually problematic, especially when they're of built-in type, and especially if they're arithmetic types, because there are no constructors, right? And it's even worse when they're floating point variables. How so? And I saw this happen. I saw a multi-million line of code project be dead in the water for about a week and a half while they went and they fixed all occurrences of this. I will explain in just a moment. Uninitialized floating point is so dire because the bit pattern that's left over, the residue, which is whatever was there from before, can be any floating point value, including even one of the bit patterns that denotes a signaling nan. Now, if you don't know what that is, stop using floating point and learn about it. There's an awful lot to floating point. The most important observation is that floating point numbers don't work like real numbers. They just don't. So all the arithmetic we were taught in 10 or 12 years of school, it's our intuition by now. It's wrong. All of it is wrong. When did your team last code with a signaling nan in mind? A signaling nan is the best example I could find of what the C++ standard refers to as a trap representation, which freely translates into you touch it and your program dies. And that's not a joke. Your program dies because there's a floating point trap if you touch a signaling nan the wrong way. So, do one of these things. Either zero initialize, all you need are empty braces, or you can do copy initialization by saying equals 0.0. Please don't say equals 0. That's just sloppy. It's the wrong type. 0 is an int. So there's got to be a conversion somewhere. Maybe it's not at runtime, but it's going to be at compile time. You're paying for it somewhere. It's just wrong. It's the wrong type. C++ is famous for being type safe. Let's take advantage of that. Or maybe 0 is not the right initial value for your application. Maybe you want to initialize it to a nan, not a signaling nan, please. Although there are use cases for that, right? Nan is short for not a number. And the standard library even has a function that gives you one. It's called nan. We got it from C. It's in CMath. You can also get it from the numeric limits in the limits header. There's a different way of getting a nan. So here are some things for you to think about. All right, here's another idiom that just irks me. I really dislike this. And I've seen these two lines separated by not only dozens, but actually hundreds of lines of code. We're initializing the variable k with our best guess, and then later on, we see if we have to change our mind. Why would you do that? Why not just initialize it to the correct value from the beginning? Why do you have to change your mind? And if you do it this way, you can't declare that variable const, even if you wanted to. Const correctness has been important in C++ for decades. And today it's more important than ever with the rise in popularity of concurrent code. Marking variables as const is important in concurrent code because you don't have to worry about those variables. You don't need locks. You don't need mutexes. You don't need anything. You can have multiple readers without interference. There's no chance of a data race. But if you declare it this way, you've defeated that. And now you do have to worry about it. So I have three possibilities for you. I like any one of these better. Here they are. The first line, notice all of these are now declared const. First line reproduces the logic of the original code. This is better because I can declare this const. The second line is even better because it uses less than instead of greater than. What's the big deal with less than? Well, in the Western world, we are trained from very young to read from left to right. And there are studies that show that we understand less than much more quickly than any other relational operator. So if you have a choice between less than and greater than, choose less than. But the third is best of all, because now I don't have to read that little algorithm and figure out what it is you're trying to do, much less, is it the right thing? You're telling me your intent, and I know it's correct because it's from the standard library. There's a reason this is in the standard library. I recommend it to you. Even small algorithms deserve names because they communicate to the reader. Code is read far more often than it's written, right? So please, make it easy for the reader. And if you don't care about your colleagues, make it easy for me, please. Okay? Some people with whom I've discussed this have said, well, I've got this variable and I need to initialize it, but the initialization logic is really complicated. Well, ever since C++ 11, we've had this tool called a lambda expression. Lambda expressions are really wonderful. And what you can do is define the lambda expression as part of the initializer, and immediately, do you see the yellow parentheses near the end? Invoke the corresponding closure. Now, I've chosen my words rather carefully. I've heard a lot of people say, well, I'm going to call this lambda. No. You can't call a lambda. It's like saying, I'm going to call 1 plus 2. No. A lambda is an expression. It's a lambda expression, and lambda is just a short way of saying that. And what does one do with an expression? One evaluates them. When you evaluate a lambda expression, you get a special kind of function object that we refer to as a closure object, or closure for short. And it has an operator parens, and that closure can be called. So that's what's happening right here. That lambda expression is going to be evaluated during the initialization of that variable. The closure will be generated, and then the closure will be called, and the resulting value will become the actual initial value of that variable. That's how lambdas work. So, something new for your toolbox, perhaps. This idiomatic use is termed an immediately invoked lambda, which is an unfortunate term, as I've just explained. Nonetheless, I've seen IIL or sometimes IILE. You're really not calling the lambda, you're calling the closure. Okay. Scope is such a fundamental thing that most of us, I believe, were taught it probably in our very first course, probably within the first few weeks. But look at this. Yeah, there are two variables named x. They're in different scopes. And we're initializing the float x with x. Keep in mind, each name has a point of declaration after which that name is in scope. And when a name is in scope, what does that mean? It means that that declaration is findable via the appropriate lookup algorithm. And as you know, there are various kinds of lookup in C++, right? So if that variable is in scope, it's with respect to a particular lookup algorithm. In this case, the point of declaration for a name is immediately after the complete declarator. And the declarator does not include the initializer. So there is the point of declaration. And now that x is in scope, which means the second x, which is the float, is initialized with its own indeterminate value, which, by the way, could be the bit pattern for signaling NaN. So don't do this. Don't let anybody else do it. Just for your information, there's a proposal being considered that would change some of this nomenclature. So if in a year or 2 or 3 you go look this up and you find different vocabulary, this would be the reason why. We may be talking about a locus of a declaration instead of a point of declaration. I don't know how that's going to go, but just letting you know what's in the pipeline. Okay, I want to spend a little bit of time on something extremely simple, at least for anybody with not much training, and the rest of us too. I can't tell you how many hundreds, if not thousands of times I've seen loops that look more or less like this. This wouldn't pass my code review. Let me explain over several pages. Here's my first question. Why post increment? That's just wrong for lots of reasons. We're not going to use the previous value of k, so why are you saying to the compiler, please make a copy of it so that you can return it for later use, and then abandon it? It's pointless. Now, I understand some of you may not be aware that there's a copy involved in a post increment. But for example, if you were writing your own post increment operator, for example, for an iterator, it almost always will look like this. And notice the first line of the body is a copy. You have to copy it so that you can return it later. That's what post increment does. So why do you want the inefficiency of an extra copy? Instead, use the pre-increment operator. Same number of keystrokes, just in a different order. And I understand there are people who will argue, oh, but the compiler will optimize it for me. Yeah, okay, maybe. Are you sure it'll do so at all optimization levels? But I don't care. Post increment here misstates the intent. It misleads. I have to look at that and say, did you really mean post increment, or are you just being stupid? I have to think about that. All right? So, in my judgment, it's a poor coding habit that hinders comprehension. You're making somebody stare at that and say, why is that a post increment? And if there's really no reason for that, you're wasting my time, which I don't appreciate. All right, so I fixed that. But there's more. Why is that a less than? Why is that a less than? I claim that's wrong, flat out wrong. And I know it's very common. If you think about it, as written, the exit condition for this loop says we leave the loop when k is greater than or equal to n. And if you put that into words, it means we have performed at least n iterations. And that's probably not what was intended. Occasionally it is, but in my experience, it's fairly rare. The likely intended exit condition is k equals n, which means we've performed exactly n iterations. So let's indicate that with a not equals. And I know 30, 40, 50 years ago, we used to teach, what if your hardware is being affected by, emissions from the sun and a bit flips? I'm sorry, when's the last time that happened to anybody in the room? Yeah, that's what I thought. Okay? There's no reason to avoid this. So I fixed that here too. Now, perhaps some of you are still not convinced, and that's okay. But let's do an experiment. Let's compare this loop as written with the identical loop that's controlled by an iterator instead of by a counter. Because you can write it that way. It's not a big deal. It looks like that. Now, there may be some of you who haven't yet been taught that subscripting is actually the equivalent of summation and indirection. This is an exact quote from the standard. An expression E1 sub an expression E2, by definition, is identical to indirect of the sum of E1 and E2. And by the way, since addition is commutative, E1 sub E2 is the same as E2 sub E1. So if you want to drive your colleagues crazy, write K sub B instead of B sub K. It means exactly the same thing. People sit there scratching their head. What? Why would you do that? Because I'm messing with you, man. So my recommendation is to use the same coding pattern everywhere. In particular, you'll notice that as soon as I transformed it to an iterator, you may be sitting there saying, well, where's the iterator? Well, a pointer is an iterator, right? Iterators, by Stefanov's own discussion, were modeled after pointers. Notice, as soon as you transform it to pointers, the not equals and the pre-increment appear almost by magic. We just do it. We don't even think about it. So I recommend we use the same coding pattern everywhere, because when loops treat counters and iterators and pointers alike, first of all, it's one less distinction for us to have to remember. The analysis just becomes very, very quick. It's a common pattern. And then when there are deviations from the pattern, it draws our attention. And it lets us reason much more effectively about our programs. Now, there's much more to counted loops. I'm not going to go deeply into this. What about the type of the counter variable? Should it be signed or unsigned? And how should you spell that type? And how should you spell the initial value? Just to show you some possibilities. And I'm not making any recommendations here. Some people have said auto, k equals 0, etc. Some people say auto and say initialize with 0u. Okay. How about using size t? How about putter diff t, which is part of the language? How about vector of whatever, : size type? How about decal type of that vector v : size type? There are lots of ways to spell more or less the same thing. Please make your choice according to what information you wish to convey, not only to the compiler, but to the reader. You should be able to justify every token in a program. Every token conveys meaning. Every token conveys meaning to someone. Now, some of you are thinking, I don't use counted loops anymore. I use the range-based for. Well, sorry, but that's no panacea either. Here's a little bit of code, an algorithm named refill. It's similar to fill, but you have a container, it's already been filled, but now we want to just change everything to a same given value. And we're using the range-based for. Well, sorry people, this won't always even compile. Nice try. Won't always compile. Often will, won't always. I'll give you a few seconds to think. Not trying to tease you, just think about it though. Okay? Think about this. If you have a vector of bool, the type can't and mustn't be referenced to bool. Because we're talking about the individual bits. You can't have a reference to a bit, right? The iteration is going to involve a temporary. That temporary is going to be a proxy for the bit in question. And you can't bind a temporary to a non-const reference type. It's a compilation error. Never been able to do that. Standard rules of reference binding. Nothing special. So this code won't always compile. You should be declaring auto-ref to infer the correct type. But, try teaching that to inexperienced programmers. It's challenging. It really is. I've been doing it for a long time now. It's challenging. Let's delve a little bit into the range-based for. The first thing that's very tempting is just to say auto E. That's really very bad, most of the time. That's because as you iterate, every element is going to be copied. And that might not even compile. For example, if you have a move-only type, like a unique putter, it won't compile. And it might misbehave at runtime. For example, if you assign to an element, you're assigning to the copy, not to the original. That's probably not what you wanted. And the performance may not be what you hoped for. If the element type is a standard string, that may be very expensive to copy. Right? So auto E is very tempting and rarely is what you want. What about auto ref E, as we've already begun to explore? It's better, but it's not perfect. It does work with const elements. It does work with modifiable elements. It allows them to be observed and mutated in place. But as we saw, it does not compile for proxy objects or for ranges that are R values. Just won't compile. Then we have auto const ref E. And that works in some limited cases. It lets you observe elements in situ, even for most proxies. But obviously you can't mutate const elements in place. And if you're tempted to put in the exact right type, be super careful that you get exactly the right type. If you say string E, you're still going to get copies. If you say string ref E, that'll fail for constant R value elements. And if you get that type even slightly wrong, here's an example. If my source is a map of K and V, key and value pair, and if you say that pair of K comma V is the element type, this is very bad. The element type is actually a pair of const K and V. And if you get that const wrong, you're going to do a conversion and a copy for every single element. And you might not even realize that's what's happening unless you think about it deeply. And keep in mind this. Let's suppose I have a factory function. Let's just name it make strings. And it gives me back a vector of string. And now I want a range base 4, and I want to iterate over the characters in the initial string in that vector. Notice, I'm not iterating over the vector. I want to iterate over that leading string, okay? And so almost always your first instinct is to write it like this. Well, keep in mind that by definition, a range-based 4 expands to that, right? And there are even some enclosing braces for the scope that I've not bothered to show you here. But this is what it turns into. By definition, this is what it turns into. And this is bad code. This is bad. This is very bad. That S, that invented variable, it refers to the leading member of a temporary vector which was gone at the end of that semicolon. It's gone. That vector is gone. You have a reference to the beginning of a non-existent string. You can't say s.begin and have it mean anything. This doesn't work. And you can do this in so many other ways, right? One function creates something, and then you say dot something else, call a second member function, and you initialize with the result of that, but you lose what happened in the first function. Fortunately, in C++20, we have a new facility, a new feature that lets us address this problem. Instead of writing this incorrect code, as we've had to do so far, often without realizing it, we now have an optional initialization statement. And not only the standard for loop has had this forever. And now we have it in the range-based for. We even have it in if statements. We have it in whiles. An optional initialization statement starting in C++20. Which means I can put in a call to make strings, extend its lifetime by creating a reference to it, and then simply say v sub 0 as my range. And this works because it extends the lifetime to the end of the loop's body. Now, of course, you don't have to put a reference there. You can make a complete copy, if you prefer, of that vector, and maybe you have a reason to do that. But now you have an easy way to do that. And that'll go away only at the end of your loop. So this is probably much better. One more example. Here's a little algorithm. You give it a container and you give it a predicate. And for each element in the container that meets the predicate, that satisfies the predicate, we push back an extra copy of that element. That's why this algorithm is named replicate if. We make a duplicate, a replica of elements that pass the predicate. And this doesn't work. Really tempting code, isn't it? Really tempting. It's wrong. I'm very fond of this quote by Steve Dewhurst. He wrote this in one of his early books, almost 20 years ago now. This function has the annoying property of working on occasion. Worst kind of bug, right? So what's wrong? As soon as you do a pushback, if it's a vector, for example, you're invalidating the iterators, potentially. Yeah, pushback invalidates iterators for vectors. Of course, if your container is a standard list, it'll work. If it's a standard deck, it sometimes works. So would the programmer who wrote this have made that mistake if the iterator had not been concealed by the range-based for? I don't know. Perhaps not. So I'm not always a fan of a range-based for. I know a lot of programmers love them. I really know that. I'm just not so sure it's as good a thing as many people think. Okay, enough about that. Let me pick on bool for a while. Assume we have a function named itWorks and it returns a bool. So if it works, return true, else return false. Thank you very much for 8 lines of code. For openers, those braces have got to go. My real estate on a screen is limited. I need to see more. Don't give me empty braces where they're not necessary. So I prefer that. Not logically different, but it's better in some sense. All right? I can see more on my screen. But I prefer to see it formatted like that. A lot of programmers don't take advantage of our eyes. The human eye is incredibly good at seeing patterns. If you line things up, the human eye is really good at picking out patterns. I urge us to take advantage of that. That's why I prefer that formatting, because now I can quickly see that in either case we're returning something. So this really should be a single return statement. And of course, you're all way ahead of me, right? This is what you really should write. I don't need 8 lines of code, I just need 1, and it's much shorter. Okay, having gone through that, you may believe that you've now seen the spectrum of ways to write this. Not even close. Let me show you others that I've seen more than once, many more times than just once. I don't know if I can stand to look at it. Okay. All right, all together. Oh, yeah, I know. I love the dichotomy We're going to either return B or else false. What? What? And did you know, by the way, that that's legal C++ syntax? You could initialize a variable there. That's been there for a very long time. That's valid syntax. Okay. Now, I actually sympathize with this code. I don't like it, but I sympathize with it because it's following local coding guidelines. Every case has a break, and every switch has a default. Please tell me you don't work in a place that has such a coding guideline. If you do, please rebel. Okay, here's more Boole-related stuff. To be or not to be. Doesn't that seem like it's a tautology? Isn't that the same as saying if true? In which case, why is it there? Just put the code there, right? I've not shown you the complete example. This is half of it. As bad as this is, there's an else. Wait, I'm not done. The else has the exact same body. See what I mean about just shaking your head at it? Yeah. All right, here's a function that asks whether something is valid. I don't think it validates very much. But, oh yeah, okay, maybe it used to be a stub for something that never got fleshed out. So I'm willing to put up with this, except it shouldn't be in production. It should have been gone by then. Either flesh it out or get rid of it. But let's use it in just a moment. In the meantime, here's a function template that somebody wrote. I think maybe to see how many times you can use the word value in different ways. Notice that parameter passage is even by value. All right? And I'm sure you figured out by now, that's an identity function, right? You give me a value, I give you back the same value. Right? Now let's put both of these into context. So we're going to return either true or a copy of false. Because the original, I guess, wasn't good enough. And by the way, lose the extra parentheses there. Just makes my life harder because I'm going to sit there saying, why are they there? And there's no good reason. Okay, I've got more Boole foolishness for you. Somebody wrote this. I guess he really wants a true flag. Again and again and again and again and again, and it never ends, right? I have no idea why this ever made it in. And I really can't figure this out. Let's try to return true, but just in case that throws an exception, we'll catch it, we'll name the exception, never use that name, but return false. Sure. Take a minute, think about this really hard. Is your brain bleeding yet? This is, if condition 1 and condition 2 do this stuff. Done. That's it. But this is the hard way, the long way, the tedious way, the way that takes me a while to say, what? Don't do that. I loved, by the way, I don't know if you noticed, the break is not aligned. I copied that. That's not a typo. That's not a mistake in transcription. It was like that. I really don't know why. But there must have been some reason, right? And people who invent their own bool, either tautology, contradiction, or not found. What? I have no idea how to use that. And if you think that's bad, you know, 2 states weren't enough, so, you know, we tried 3. But if 3 is not enough, maybe so. It's either always, usually, often, sometimes, rarely, or never so. Yeah. Okay. I'm done talking about bool. Let's talk about arithmetic. I love this quote by Babbage. I wish these calculations had been executed by steam. Well, that was the state of the art 200 and some years ago, right? Okay. One of the simplest things we can do in arithmetic is to add up numbers. So let's start with a little example. Let's just assume for the sake of the example that we have 3-digit decimal numbers. Okay? And let's add 1.00 plus 0.999 and then add 0.001. And what happens is at the first summation, the last 9 gets dropped on the floor because you only have 3 digits. So the last one is gone. And then when you try to add 0.001, there's no place to put it, so it gets dropped also. And the total is 1.99. Yes, welcome to floating point. But if you happen to add them in the opposite order, your answer is 2. Because 0.001 plus 0.999 gives you 1.00 plus another 1.00, and so you get 2.00, right? Yes, welcome to floating point. So the moral of the story is, whenever possible, sum your smallest values first. And that way you you don't eliminate it, but you reduce the risk of what's called loss of significance. You just don't have enough bits to hold the result. So you might want to write a little algorithm. This might be the first draft. Give me the from and the up to, and I'll sort it, and only then will I do the accumulate. Oh, by the way, did you catch the bug? That shouldn't be 0. It should be 0.0. The type matters. It really does. And if instead of writing 0.0, you just write in double with empty braces, and then someday somebody comes along and makes a template out of this, they'll change it everywhere. Because it says double in several places, so we'll change them all to, for example, T. They won't forget and leave the 0.0 there. All right? Try to future-proof the code. By the way, it's not right. What if we have some negative values in there? Or maybe if they're all negative, I've done exactly the wrong thing. I'll sum the largest values in magnitude first. Yes, you want them in order smallest magnitude to largest magnitude. So it should be something more like this. Here's a predicate to ask about orders taking the magnitude into account. And then here's my rewritten function. Sort them according to magnitude. And now this will do what I want. And by the way, this approach helps with integral values too, because it reduces, again, it doesn't eliminate, but it reduces the risk of overflow. So in the general case, you worry about summing values that can have very large values or very small values or have mixed signs, always things to think about and worry about. Now, what about the midpoint? And of course, we had a talk on that topic at this meeting, a very fine talk. But how would you code, if you didn't attend that talk, how would you code calculating the average? Sum and divide by 2, sum individually and then, divide individually and then sum? Or would you calculate the delta and then add it? There's a famous bug that was in the Bell Labs implementation of binary search, something like 30, 40, 50, maybe 50 years ago. It was there for something like 20 years until memories became big enough that A plus B overflowed. Famous bug. And by the way, don't just think about midpoint. Think about the more general algorithm, linear interpolation, usually known as LERP. All right? Midpoint is just one special case of LERP when t is 0.5. Just think about that. And so that you don't have to think too hard, you should know that both midpoint and LERP will probably appear in C++20 standard library. But again, what are the issues? For most arithmetic, you worry about integer overflow. You worry about excessive truncation. For floating point, you worry about underflow. You worry about denormalized numbers. If you don't know what those are, stop doing floating point. Quiet nands, signaling nands, infinities, yes, plural. There's a positive and negative infinity. 0 is signed. Yes, there's a -0. You should be aware of that. You should worry about what the rounding mode is. Do you round up? Do you round down? Do you round to the nearest? Do you round to the nearest even? There are rounding modes. And the frequency of rounding. Obviously, the fewer the better. And we should code accordingly. By the way, if you are doing midpoint of unsigned ints and or pointer types for that matter, do the calculate the difference and the delta and then add. If A is less than or equal to B. If A is less than or equal to B. Again, there's a talk just on this topic. I recommend it to you. But I'd also like to show you how difficult it gets when you have to think about midpoint for floating point types. If you can safely sum A and B, then you can do A plus B over 2. Of course, we have to worry about how to figure out if it's safe to do that. And if it's not safe to do that, then we want safely to take half of A and add it to the safe half of B. So, of course, the special sauce is in the helpers. But I also want to recommend this reference to you. This article is 50 years old. It should be required reading for anybody who does serious floating point. Pitfalls in Computation, or Why a Math Book Isn't Enough. Very important article. So here are my helpers. You can safely sum if both of the numbers are less than half of the available range. And how do you figure that out? You appeal to numeric limits, : max. To figure out if you can safely have, look at numeric limits, : min. If you haven't looked at that before, it's probably not what you believe it is. It's the smallest positive floating point value that can be represented, normalized. And if you can safely have, then how do you do the safe half? Well, if you can do it safely, you divide it by 2. If you can't, then it's such a small number which we're going to add to a very large number, that it makes no difference. Just leave the number alone. And this will work. This is not the way I would code it in practice, but for exposition, I think this makes things quite clear. There is almost no computer arithmetic that is simple, because it's all finite. And that's not the arithmetic that we were taught in schools. So our intuition is often just wrong. And we have to fight that intuition if you're going to do serious numeric work. If you have two floating point numbers that are nearly equal and you try to subtract them, you're going to lose significance. The phenomenon is called catastrophic cancellation. A whole lot of bits just become zero, and the ones you care about are all the way over to the right. And there aren't very many of them left. Here's an example. Take the square root of x plus 1 and the square root of x and subtract. That is not accurate when x is greater than 1. It just isn't. But about 30 seconds of algebra turns this expression, which is absolutely equivalent and does not have the same issues. We need to be aware of these, and this is just a really simple example. If you have even medium-sized ints and you're multiplying, you're risking overflow, which is undefined behavior. There are summation algorithms, but not many of us programmers have heard of them. They compensate somewhat for the pitfalls of finite arithmetic. There's an algorithm initially by Kahan, improved by Neumeier. There's another algorithm called pairwise summation. There are others. We should consider using them in certain circumstances. We at least should be aware that they exist so that we can look them up. We still deal with some older programs that used to use long double to mimic, say, 48-bit integers when 32 bits weren't enough. Those programs are still around. But nowadays we have the long type, which is typically 64 bits, right? But unless your floating point number is mimicking an int, don't compare floating point numbers for exact equality. It's occasionally the right thing to do, but very rarely. A former student of mine contacted me early this millennium. Turns out he had been working for the New York Stock Exchange during the period when they were converting from quoting stock prices in eighths of a dollar to a full-blown decimal system, pennies. And he reported that he remembered that I had taught him this. And his code worked out of the box. And his colleagues were coming to him saying, "What did you do? What did you do? What did you do?" And he taught them. That's important. You never know what little fact makes your code right, as opposed to tempting but wrong. So let me challenge you with a little puzzle here. Suppose I want a number n never to be positive. If it starts out positive, give me the equivalent negative number. If it's already negative or 0, leave it alone. How would you code that? Here's someone's attempt. And here's someone else's. And here's a third attempt. And a fourth. I mean, this is not a hard problem. Should there really be so many ways of coding this? Here's a fifth. Yeah, I know. All right, take a deep breath, everybody. I don't even understand the predicate in the first if. That's essentially saying if n is not 0, why are you bothering with negative n? But okay. There are programmers for whom the solution to every problem is to put a string in there in a regular expression. Don't underestimate that. Yeah. This trips up, I've discovered, a lot of programmers in C++. The division operator and the percent operator when negative numbers are involved. And what about this? Well, the answer for both divisions is -7. All right? Sorry, -7 and +7. But what do you get for the others? I've also discovered that a lot of programmers don't even know the proper name of that percent operator. I've heard most programmers call it the mod or modulus operator. It's not. It only gives you the mod if you're not dealing with negative values. It's not mod. Proper name? I'm quoting the standard. It's the remainder operator. It's what we learned in grade school, in elementary school. You divide, and then there's a remainder. It's before we learned fractions. That's what the percent operator gives you. It's the remainder after integer division. And there's the full definition of how it operates. I'll let you look it up if you care to. Here's another puzzle. If I have a number n, an int, how do I decide whether it's odd? Do you take the remainder and see if it's 1? It's a possibility. Do you do bit manipulation? Do you look at the right, you mask off all the other bits and see if the rightmost bit is 1? Maybe. Or you can do that. Believe it or not, this works. Not well. Awful lot of recursion involved. Yeah, really. See what I mean about just shaking your head at some code? Yeah. What would I do? I'd first write is even. And then it's odd if it's not even. That's what I would do. And I have. Probably hundreds of times. Well, sometimes we're forced into doing things because the world is really not often logical, and we just have to cope with it. Here are some of my favorite examples of logic. 59 plus 1 is 0 every minute, unless there's a leap second, in which case 59 plus 1 is 60, and 60 plus 1 is 0, which happens occasionally. Love plus 1 is 15, plus 1 is 30, plus 1 is 40, plus 1 is game. Not my idea of arithmetic, but okay. In music, if you go up by a third and then up by a fifth, you've gone up by a seventh. I checked with a musician. That's true. That's correct, as I'm sure many of you know. Or take your house number. Add 1. Is that your neighbor's house number? Most of the time, it's not. Sometimes your house number isn't even the number. Right? But consider arithmetic and pop culture. In the arithmetic of love, 1 plus 1 equals everything, and 2 minus 1 equals nothing. Sure, why not? Or the definition of arithmetic. Arithmetic is being able to count up to 20 without taking off your shoes. Thus saith Mickey Mouse. Or Mr. Spock, computer, compute to the last digit the value of pi. Thank you very much. We'll be here a while. Here's my all-time favorite. In case you can't read the lettering on the picture, I've duplicated it at the right. Okay? Toilet paper arithmetic. I don't get it. I don't get it. And you know, it's really unfortunate, but there's publications that give us misinformation, and that's really unfortunate. Let me give you just one small example. There's a book that claims that every operator has a precedence and then defines precedence as a specified order in which the expressions are evaluated. I have heard this for 40, 50 years now, even longer actually. It has never been true. And perhaps you were taught this. It's wrong. It has never been true. Precedence certainly influences the order of evaluation, sure. But in other than trivial cases, it does not determine the order of evaluation. And it doesn't help that this book is in its 7th edition. It's been around a long time. It's been wrong for a long time. What is the correct role of precedence? Precedence determines what operands go with which operators. That's it. That's everything. And if there are ties, that's what associativity is for. They're the tiebreakers. And what that does is let your compiler build the expression tree. I mean, here's a trivial example, right? 2 plus 3 times 4, the tree looks approximately like that. But if you put in parentheses, the tree suddenly looks like that. Notice the tree has no parentheses in it. That's important. And then so what? Now you have a tree. How do I get my results? Well, all right. The association of operator and operand. How do I get my results? Expression evaluation uses a different algorithm that uses that tree. It traverses the tree. A traversal is a systematic walk, as I'm sure most of you know. You walk the expression tree, and along the way you apply each operator to its operands. And those operands are ultimately evaluated expression subtrees, right? And you get both what are called value computations and side effects as you go. By the way, in case you didn't know, C++17 changed the order of evaluation for a number of binary operators. Usually we specified order only at what were called sequence points. Those are gone now. We don't talk about those anymore. In assignment operators, the right operand, or if you prefer, the subtree corresponding to the right operand, is sequenced before, which means it's evaluated before, the left operand, which is the target of the assignment. But that's for assignment operators. Essentially everywhere else, and I'm cheating here a little bit, but this is an easier rule to remember. In other binary operators, the left operand is sequenced before the right. Okay? And those are the rules now as of C++17. Okay. Let me quote some people whom I respect and share their advice with you. In general terms, it's up to the artist to use language that can be understood, not hide it in some private code. Obscurity is usually the refuge of incompetence. Robert Heinlein. Just change one word. Just change one word. It's up to the programmer to use language that can be understood. Somebody else. The difficulty of literature is not to write, but to write what you mean. Not to affect your reader, but to affect him precisely as you wish. Let's change just a couple of words. Robert Louis Stevenson. The difficulty of software is not to code, but to code what you mean. Not to affect your computer, but to affect it precisely as you wish. No more changes. As soon as we started programming, we found to our surprise that it wasn't as easy to get programs right as we had thought. Debugging had to be discovered. I can remember when I realized that a large part of my life from then on was going to be spent in finding mistakes in my own programs. Yeah, 70 years ago. 70 years ago. That's within my lifetime, people. Yeah. Debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are by definition not smart enough to debug it. 45 years ago, we knew this. Still true. Even though the compiler is supposed to be helpful, it also treats you like an adult. Our friend John, who's here. The farther away that I need to look for an answer, the longer it takes to comprehend code. From a talk earlier this year. Yeah, on reading code. Then there are those beautiful snowflake-like cases of abuse. Those moments where you see the code, you understand the code, and you wish that somehow you could throttle the person responsible for that code. Yes. Many of the examples I showed you today. Yeah. You think you've had harsh code reviews? Listen to this one. Your code is 100% bogus and should be taken out the back, lined up against the wall, and machine gunned. Then the corpse should be hung, drawn, and quartered. Then burnt. Then the smoldering rubble should be jumped up and down on by a hippo. Yes, Dave Korn. Corn shell? Yeah, Dave Korn. Always code as if the programmer who ends up maintaining your code will be a violent psychopath who knows where you live. Life would be so much easier if we could just look at the source code, right? How bad can code really get? Yeah, I got more. What I'm about to show you is just shockingly inane. It was written by a very highly paid consultant who obviously didn't test it. The intent of this code is to just produce an all-caps version of the function parameter s. Just shake your head. Close your eyes if you have to. There is nothing about this that's right. Nothing. There's a result string that is never touched except to return it. There's a special case to say, is S empty, in which case we'll return a new empty string. But it was empty in the first place. So why bother? And by the way, we already constructed an empty string in result. So let's do an extra, okay, fine. And then we'll use an algorithm. For each of the characters, we're going to convert it to upper. It's the wrong algorithm. You want transform, not for each. This doesn't change anything. Nothing. It certainly doesn't touch result. I couldn't believe this when I saw it. Could not believe it. How did this survive? I don't know. Clearly untested. Here are some other great small code fragments. If tote equals 1, return 1, otherwise return tote. What? I'm going through a lot of trouble to return tote, I think, but okay. Yeah, I don't think so. Would you like maybe to throw that exception? I don't mind your constructing it, but you really should do something with it. Love this. If the string is not empty, and because we always wear a belt and suspenders, we'll also check the length and return true, otherwise fall through and return false. Now, it may take you an extra 30 or 50 seconds or so to realize this does absolutely the wrong thing. It is absolutely backwards, according to what it's named. If this is not provided, it should be returning true, but it's not. And by the way, don't we have this in the standard library? Yes, we do. Let's just use it. All right, this is not bad. It's naive perhaps, but it's not terrible. It's busy waiting. So there's some variable busy that some other thread is going to touch, and until it becomes false, we're just going to spin here. Not great, but it does work. Unless you put it into a different context, like this, where busy is suddenly a parameter, passed by value. No other thread can touch this value. It's a copy. It'll never change. It's either true or else it's false. It never changes. So, this is, well, you decide. All right. So we start with a pair of defines. I know a lot of us don't like to use the preprocessor, but sometimes you have to. So this is not terrible. Define success is 1 and failure is 2. And now we have some badly named function that returns a bool. So if something succeeded, we return success, otherwise we return failure, and both those ints get converted to bool, and neither one is 0, so this always returns true. Yeah, I know. I don't understand the purpose of this function. Can't you just take the address of the invoking object? I don't know why this function exists, member function exists. And then, now, I'm going to show you what is a real algorithm, real bad, but it's documented. It's named BogosSort for bogus sort. This is the equivalent of sorting a deck of cards by dropping them on the floor, picking them up and saying, okay, are you sorted? No? Let's drop them again and pick them up differently. Okay? By the way, if you analyze this algorithm, it's of order n times n factorial. in complexity. Okay? Now, I am not showing you this because it's such a horrible algorithm. I mean, it's of at least academic interest, if nothing else. But it's badly coded. What am I talking about? Well, it's using the new shuffle algorithm from the standard library, which is fine. And one of the arguments to the shuffle algorithm is a source of random bits. And so there's an entity called default random engine in the standard library. That's fine. But he constructs one on every iteration, the same one on every iteration. Doesn't reseed it, doesn't keep going from where you left off. It's a fresh one on every iteration. No. Bad algorithm, done really badly. I can't actually show you this code, so just please imagine you have a copy assignment operator, and the body has two different implementations accomplished via, macro magic. In debug mode, it performs the traditional deep copy that we would all expect. But for performance reasons, in production, to save time, it does a shallow copy. So if you change the original, like off in some other thread, you're also changing the copy. But in debug mode, they're independent objects, each with its own lifetime. So the race condition that underlies all this will never manifest in debug mode. Imagine trying to debug this. Yeah. Have mercy. Have mercy. Here's how not to close a bug report. Yep, for real. And one of my all-time favorite comments in code. When I wrote this code, only God and I knew what's going on. Now, only God knows. And so, we have responsibilities. Programming is a profession. It's an ethical obligation to work to improve our profession. And the more senior and the more talented you are, the more you owe to the community. Part of that obligation is to continue to study, to read papers, and to work through books. Yes. The difference between amateurs and professionals. Amateurs have a goal. Professionals have a process. Amateurs think they're good at everything. Professionals understand their circles of competence. Amateurs see feedback and coaching as a blow to their ego. How dare you? Professionals know they have weak spots and seek out thoughtful criticism. Amateurs think knowledge is power. Professionals pass on wisdom and advice. Amateurs blame others. Professionals accept responsibility. As I think many of you may know, ever since I've retired, I've been giving a few public talks. It sometimes happens that during a talk I go off script and say things I didn't intend to say. Occasionally, I stick my foot in my mouth, but occasionally I say some things off script that with hindsight I really like. Please permit me to share one with you. I mean, there's a certain level of arrogance in our profession. You find the same sort of thing in lots of professions, like surgeons, for example. You have to be sort of ultimately confident in your abilities to get the job done. But a good surgeon knows when not to cut. A good programmer should know when not to code. If you don't have the expertise, either get it or say no. It's the professional thing to do. Okay? I kind of like that. Thank you. So I ask myself, do I have a problem? Because I admit I don't like all programmers the same. I don't. I am biased, yes. But it's not because of ethnicity or religion or politics or gender or any of that other nonsense. None of that bothers me. And it's certainly not because there are programmers who use Ada, APL, C, COBOL, Fortran, Go, Haskell, Java, JavaScript, Lisp, PL1, Python, Ruby, Rust, Swift, or anything else that's not C++. That doesn't really bother me. I wish we would always use C++, but I've been doing it for 40 years now. 40 years I've been programming in C++. I don't think I have a problem. I think I'm just a zealot. I don't like programmers who are just professionally incompetent. Those who demonstrate inadequacy at our craft and who refuse at the same time to learn to do better. Not only do coders like that make our jobs harder, but they don't really care that their own lack of skill and of good judgment causes others to suffer, as long as they get paid. This bothers me. So who are those programmers? I invite you, just read their code. You'll recognize them. Thank you all very much. Have a safe trip home. Thank you. Thank you.